Also, the past the pot to grandma would imply that this is something she should do now, not 50 years ago, right? Yes.
Hop in a time travel machine. Pass the pot to grandma when she was 15.
Right. Welcome to Normal Curves. This is a podcast for anyone who wants to learn about scientific studies and the statistics behind them. I'm Kristen Sinani. I'm a professor at Stanford University.
And I'm Regina Nuzzo. I'm a professor at Gallaudet University and part-time lecturer at Stanford.
We are not medical doctors. We are PhDs, so nothing in this podcast should be construed as medical advice.
Also, this podcast is separate from our day jobs at Stanford and Gallaudet University. Kristen, today we're talking about weed.
You're not talking about the kind that grows in your yard, right?
No, the fun kind. Cannabis, marijuana, pot.
Oh, I think, Regina, this might be our first episode on recreational drugs.
I think you are right. It seemed like it was about time to move on from our usual sex to drugs.
Rock and roll. We need rock and roll in there.
Okay, so cannabis, there is a lot of research on it, of course, that we can talk about, but it was one recent paper that caught my eye. Let me read you a headline, and I think you will see why I was intrigued. Okay, from the New York Post, the headline was this: researchers surprised by the brain benefits of cannabis usage in adults over 40. And the subhead was, pass the pot to grandma, her brain might thank you.
Okay, I'm immediately skeptical, and I can see why you were intrigued by this one. Brain benefits, really? It seems unexpected and surprising, which of course is the kind of thing that gets headlines, but is also the kind of thing when we're a little skeptical. Regina, I believe you have tried cannabis.
Yes, for the record, I have used cannabis before, and also for the record, I am over 40. So I will take any brain benefits I can get.
And of course, you've only done it when it was legal. Let's just put that disclaimer in. I'm not a cannabis user, and I have to say I am a little skeptical because you think of potheads, you don't really think of, oh, this is going to make me smarter. And actually, Regina, we grew up in the 80s, and do you remember the commercials with the frying pan and the egg? This is your brain on drugs, right? The implication being you're frying your brain.
I think it's a meme now.
Is it a meme? Okay, so young people know about it. Okay, yeah. So you do associate drug usage, recreational drug usage, with maybe not being so good for your brain.
It's true. There has been a lot of research on why pot is bad for teenagers' brains, right? And we're going to cover that in another episode. But of course, I couldn't resist the promise that we could all just sit around, get high every night and say, hey, it's like a vitamin. Preventive medicine here. I'm not enjoying it at all. It's just for my health.
It's reminding me a little bit, Regina, of the episode we did on alcohol, because people used to say, oh, I'm drinking alcohol for my heart. It benefits my heart. And we kind of debunked that one.
Yeah.
This could be similar, right?
Let's just keep an open mind. That is all I have to say, Kristen. We want to see what the evidence says.
Okay.
But it's good to know our human biases.
I'm keeping an open mind, as I did with the hot tub training episode as well. If there's a shortcut to good health, I'm all for it.
I feel like lazy life hacks, it's the way to go. I'm into that these days.
We're having a theme here.
We are having
the last few episodes, yes.
Theme. Yep. Okay, so let me tell you the claim that we're going to look at today. Middle-aged and older adults who use cannabis will see brain and cognitive benefits.
That is a bold claim.
But Kristen, have you heard about the book Marijuana Reconsidered? It was written by a Harvard psychiatrist.
No, I'm not familiar with that work of literature.
Okay, it was by a guy named Lester Grinspoon, and it makes the case that cannabis is actually not as harmful as people have thought.
Oh.
But guess when the book was published?
When?
1971.
Oh, wow. So he was a little ahead of his time, because now people are coming around to this idea that pot might not be as harmful as we once thought, right?
55 years ago. So it was interesting. Grinspoon set out to study cannabis when he saw that his friend and Harvard colleague, Carl Sagan, was a big pothead.
No way.
Yeah. And Grinspoon really wanted to show Sagan why pot was bad for his health and to try to convince him not to smoke anymore. So he decided to go in and start looking at all the literature. And then he realized, oh, wait a minute, maybe it's not as bad for adults as people say, and is actually less bad, he concluded, than alcohol.
Oh, wow. So he went in skeptical and came out actually thinking it might not be so bad. Interesting.
He was a huge proponent, and this book got a lot of attention, and Richard Nixon was quite annoyed with him because he was suggesting that marijuana be legalized. But, okay, fun side fact.
Okay.
His son, David Grinspoon, is an astrobiologist and science writer and psychedelics researcher, and he lives in Washington, D.C., and I went to a party at his house once.
Really? Wait, was this a psychedelic party, Regina? Do tell.
I did not do drugs at the party.
Did other people do drugs at the party?
Just for the record, I will not comment on that.
Okay. We'll leave that one to everyone's imagination.
There
You know, I have to tell this story. So the boyfriend I was dating when I met you, he did occasionally partake in the occasional pot smoking. So I remember I was at a bar once, and I have this very distinct memory sitting in the bar. I guess I was meeting him at the bar, but he comes up to me, hi, and is like, I finally get statistics. He had this epiphany that all of statistics made sense to him and the beauty of statistics. And so it's like he got my world for just a minute there, you know?
You were validated. You were appreciated.
Right, exactly. For just a little minute, he had it. And then I think after the high wore off, he lost it. I will never forget that moment because it was like statistics was this thing that finally was in his brain and made all sense.
Well, this is what Carl Sagan said in that book. There was actually an essay from Carl Sagan, but they anonymized it. It was talking about his marijuana experience, and he said it was just transcendental.
Right. Maybe that all of his big thoughts came during.
That was what he said. He said that we spend most of our life avoiding all of this communion with the world, with the natural world and the spiritual world, and that marijuana let him do that.
My boyfriend was communing with statistics. Yes, absolutely. Okay, Regina, I honestly don't actually know too much about weed, but what would be the biological explanation? How would weed actually benefit your brain?
So the researchers here did cite a study that I will tell you about. It's supposed to be good not for all brains, but for middle-aged and older brains in mice.
Yeah, but mice research, how applicable is it to humans?
The good thing about mice is they don't live as long as humans, and you can do things like randomize them to become potheads or not.
I do like the randomization part. So in other words, they made a bunch of pothead mice is what you're telling me.
So they did this fascinating experiment where they had these groups of mice. They had young mice, middle-aged mice, and older mice, and the researchers kept them all constantly just a little bit high. 24/7 for a month at a time. But remember, mice don't live as long. So if you translate that into human time, it would be like humans being constantly high for like a few years at a time.
Oh, wow.
Okay, so they had the pothead mice, and then they also had the poor control mice for each age group. They did not get any weed, so I think of those as the Nancy Reagan Just Say No mice. So we had the Just Say No, poor nerdy mice, and then we had the pothead mice. And so I'm getting flashbacks to high school. I don't know about you, but I was over in the nerdy side, definitely.
I was definitely in the nerdy side, yes. But how did they give the weed to the mice? Did they smoke? They can't smoke it, right? So gummies? Like what? Yeah.
I know. I was hoping they had little mousy bongs, you know, or like smoke-filled cages.
They could just pump in the smoke.
I know.
Oh, yeah, that would work, yeah.
Like
it might be bad for the lungs, though.
Like Hunter. Maybe. No, they just gave them an IV weed drip.
Okay. That's boring.
Well, I don't know. It's kind of fun because they were high even when they were asleep. Okay, so mice were high for a month. Then they gave them cognitive tests. And
they go through a maze?
Go through a maze. I'm sure it was all mazes.
Okay.
What else do mice do all the time? And so after a month of partying, you would expect that the middle-aged and older mice that were stoned would do worse than their control mice. No, they did better. Than the control mice of the same age. Okay. In fact, they did so well. In one test, they did as well as the young control mice. And the researchers said it was like the cannabis reversed cognitive aging in these mice. But the young mice did worse than their abstaining peers.
Oh, so bad for young brains.
Yes.
Okay, so the pot made the old mice smarter and the young mice dumber. Is that what you're telling me?
And then the researchers looked at their brains and they saw differences in the hippocampus that supported this entire story. The older stoner brains had more synapses, more connections. They looked almost like the young control brains. And the young stoner brains looked like the old ones.
This is very surprising. Is there a biological reason?
Yeah. Now, I'm not a neuroscientist, so I was trying to read through the jargon, but it looks like it's about neuroplasticity. When we're young, our brains are nice and plastic, and we can grow connections and rebuild connections. And we get older, we kind of lose that ability, which is why we also lose our phone and the glasses on top of our heads, right? And we
yes, constantly.
Constantly. That's because our brains aren't as plastic. Now, it looks like THC, which is the fun chemical in cannabis that makes you high. That's the psychoactive part. It is working with the cannabinoid receptors in different parts of your brain, and it might increase the plasticity, the neuroplasticity in your brain. And we need that. This is great for our older, fossilized brains. We need a little more plasticity, but it can be bad for the young brains that are already plastic. You don't want to be too plastic.
Oh, interesting.
Yeah, it can be a little too chaotic and disruptive.
Oh, that makes
brains.
sense. Okay, yeah.
So old people can say, yep, I'm going to do it, but you kids, sorry, you're not allowed to have any.
Okay, I mean, that sounds plausible when you say it like that maybe this is correct and this study in mice is compelling. I don't know how many mice were studied and how good the study was, but assuming it's a good study. But of course, even if it's true in mice, not necessarily true in humans. Do we have studies in humans?
Well, there have been studies in humans. I want to talk about this particular one because it got the headlines, this recent one. So it's published just recently, July 2026, in the Journal of Studies of Alcohol and Drugs. And the senior author actually at University of Colorado, Anschutz. Colorado is one of the leading states to legalize recreational cannabis. So the researchers used the UK Biobank database.
Oh, we've talked about UK Biobank before on this podcast in the alcohol episode.
So UK Biobank, huge study in the UK. They recruited more than 500,000 people.
It's huge.
And this was only in individuals between 40 and 70. And they collected lots of different types of data, in different people. So some of them, they had the DNA data and they had maybe lifestyle information. And as we'll talk about here, they also, on some of them, got brain imaging data and cognitive test data. And the researchers for this study used a sample of over 25,000 people. That was everyone who had the MRI neuroimaging data, and almost half were in their 60s of this group, and they were mostly the baby boomer generation. So keep that in mind when we talk about who is smoking pot and who is not. They were about half female, mostly white, and living near big cities. So that tells you about the type of people they were. And they asked about cannabis use as part of the lifestyle data. And here is the question that they asked. Have you used cannabis, even if it was a long time ago? And then, Kristen, it was funny. They said, just in case you don't know what cannabis was, they gave you a bunch of other names for it. And these just cracked me up. Marijuana, grass, hash, ganja, blow, draw, skunk, weed, spliff, and dope.
Oh, I didn't actually know all of those referred specifically to pot.
I thought blow was cocaine.
I did too, yeah. Wow. I thought dope meant just drugs. No?
I know. Yeah.
I guess I'm not up in my drug lingo.
I think
Mary Jane. Isn't it called Mary Jane?
How did you know
It's in a movie.
That? How did you know? It is called Mary Jane.
Yeah, I know that one. They didn't use the word pot?
Not pot. Or reefer. Remember that old movie from the 30s, Reefer Madness?
No. I don't know
they had
that
wacky tobacco. They had their...
I'm unfamiliar with this.
The wacky tobacco cigarettes, and they had people that were getting stoned and dancing kind of crazy, and it was
in the 30s? Wow, that's very bold for a 30s movie.
It was a propaganda anti-marijuana video where it's like, don't let your kids do this wacky tobacco.
Like
reefer madness.
Pre-Nancy Reagan. Wow.
Pre-Nancy Reagan. Okay, so they did get information about their cannabis usage.
But if I'm hearing right, they just asked, have you ever used it? And it's like a yes-no question?
It was not actually a yes-no question.
Oh, okay, good.
UK Biobank, they had 5 responses to choose from. They could say, no, never used it before. Yes, 1 to 2 times. Yes, 3 to 10 times. yes 11 to 100 times, or yes more than 100 times.
Okay, and they're asking about your entire lifetime. Have you used it 100 times cumulatively?
But here, Kristen, is a weird thing that they did. So instead of keeping this question with those 5 categories, they collapsed it all down to 3 categories. 0 times using pot in their lifetime, anywhere between 1 and 100 times, which they called moderate usage, or over 100 times, which they called heavy usage.
Okay, so as a statistician, I don't like this.
Yep.
So let me just make my little rant and complaint here. 1 to 100 is a very wide range, and once in your life is moderate usage. Why collapse the data? This is something that really bugs me because often people don't realize you can keep the data in its ordinal form with all the categories.
Now, they did say, it's because 100 times refers to chronic heavy usage, and this is correlated with worse outcomes. And then they provided a bunch of references, to back this up. But then I went and pulled the references. Never said, over 100 times is associated with bad outcomes of anything.
Like 100 just sounds like a lot to me when I first think about it. But then if you start to do the math, if you're talking about a 60-year-old and you did it 5 times a year for 20 years, right? 5 times 20 is 100. And this is the problem with these very vague categories, right? We could be talking about somebody who's used it a couple times a year for many, many, many years. But it also could be somebody who had a period of time in their youth where they were constantly stoned like the mice.
Right.
And those might have very different effects on the brain.
Like if you're just doing it 1 time a year, or twice a year.
And they're calling that heavy chronic usage. It doesn't really seem to match that adjective. Maybe if you did 100 times in the last year.
Yes.
But not over your lifetime.
Last month. Or the last week.
Right, exactly, yes.
This would be, and of course, what do we mean use? Do you take 1 hit?
That's true, right.
1 gummy?
One gummy.
Dosage matters here as well.
Yeah. Okay, so that was lifetime usage. Did they ask them, how frequently are you using cannabis now so we can get at current usage?
Nope.
Not at all?
No, nothing. They did not ask anything about current cannabis usage.
Because you'd think that would be the most relevant to, your current brain function, right? If you were going to find an association, you look for things associated in time often, right?
Right, as you pointed out, if I did this once 50 years ago.
Right, exactly. Whereas
today.
Currently, and also the past the potogramma would imply that this is something she should do now, not 50 years ago, right? Yes.
Hop in a time travel machine. Past the potogramma when she was 15.
Right. Well, and also the mice study would indicate this is something that if you want the benefits, it would be done when you're middle-aged or older. So they ought to know if you're doing it now.
Yeah, you would think. This is crazy, right? So well, you, Kristen, are going to love the line of logic that they follow to get to passing the pot to grandma.
Okay.
We are going to see that, how it gets translated from the data to the press release to the media.
Right. So this somebody might have overstretched the conclusions of this study, is what you're saying. Yes. Okay. So we have a measure of cannabis use. It's not a great one. And you said they were trying to relate this to cognitive function. So how did they measure cognitive function?
So they had these brain MRI scans and they had cognitive tests.
Okay.
And the University of Colorado researchers chose 18 particular brain regions to focus on, to look at. Instead of just analyzing the entire brain voxel by voxel, they chose 18 named regions.
So out of these they all had an MRI, and out of these MRIs, they get pictures of these different regions of the brain, and then there's data that you extract from that, such as what?
So here they were looking at the size. They could look at the structure, and they could see how big your hippocampus is or how big your amygdala is.
You're kind of getting a map, and then you can measure the volume of that part of the brain. And is more volume better?
It is, actually.
It is? Okay.
Bigger is better. Yes, it is. I did that one for you, yes. So they had 9 on each side, and they wanted to see, if those different cannabis groups, right, the 3 groups that we talked about, if the more cannabis usage you'd had in your lifetime was any of these brain regions bigger
Okay. And you said there was 18 brain regions. Is that all that the MRI measures, or does it measure a lot more and they just picked 18?
They chose 18.
Did they cherry pick them, or did they have a reason?
Well, they did not pre-register as far as I can tell, but they said that they chose the ones that were rich in these cannabinoid receptors. These are the regions of the brain that are likely to be most receptive to cannabis.
Right.
So you might say, why bigger is better?
Yeah.
Like how do we know about that? It's only a marker of aging. Studies have shown that larger brain volumes are associated with better cognition as we age, but it's just a proxy.
Does your brain shrink as you age?
Yeah, it does.
Oh, no, really?
It is.
Oh, how horrible.
It's sad, isn't it? It literally shrinks.
Oh, so if you shrink less, you lose less cognitive function? Okay, I guess that makes sense.
That's the idea.
You're losing less neurons or something.
Yeah.
But it's a proxy, so it's not a one-to-one. Oh, if your brain grows an inch, you're going to get smarter, right? It's just an association, yes. Okay.
Exactly.
So did they measure actual cognitive function in any way then?
They did. They had a choice of 14 different little cognitive tests that the UK Biobank people gave to the participants. And these researchers chose 7 of those 14 that, again, they thought would be most associated with this cognitive aging and most affected by cannabis.
Oh, interesting. Again, so there's a little worry about cherry picking here, but you're saying that at least they're telling us that they pre-chose these for a specific reason, and it wasn't that they chose them after looking at the data, and we just have to trust them.
Yes,
okay.
Exactly.
Okay, so to sum up, we have this crude measure of lifetime pot use. We have some data on how big different regions of the brain are, and we have some cognitive tests. And from that, we're going to now understand how we get from that to grandma should use pot.
Yes.
Okay, so I think we're ready to talk about what they've actually found, but let's take a short break first. Regina, I want to tell people about our course on Stanford Online, Demystifying Data. If you like how we teach here on the podcast, using case studies, real examples, and intuitive explanations, that's exactly what this course does.
Yeah, it's basically normal curves, but in course form.
Yes. So if you've ever dreaded statistics or felt intimidated by it in the past, this course is designed for you.
And there's good news on the price.
Yes, because so many people asked for it, Stanford Online has lowered the price of the course to make it more accessible. We are really excited about this and hope that it means that more people can take the course and feel more confident working with data. You can link to that course from normalcurves.com. Welcome back to Normal Curves. Today we're talking about a study that looked at whether pot is good for your brain as you get older, and now we're ready to hear about the results. So, Regina, what did they find?
Well, first of all, let me say, out of the more than 25,000 people they had data on, 77% said that they had never tried weed before.
Okay. So I'm in the majority.
You're in the
majority.
You're not. I am not.
Is pot legal in the UK?
That's a good question. I looked it up. From what I can tell, it is not legal. And for most of when the data were collected, it was either not legal or highly illegal. And for most of the lifetime of these participants, it had been quite illegal as well.
So we do have to keep in mind in interpreting this question, it's not a question that tells us who used pot. It's a question that tells us who was willing to admit that they used pot. So part of that 77% could be people who indeed used pot but were afraid to admit it because it was illegal and they might have been afraid of getting in trouble. So I think that's important to keep in mind.
I think so. If these official people from the UK government are sitting down and saying, okay.
Right. It's a government study. Yeah. They might be afraid it could be traced back to you, right?
Oh, yeah. More than 100 times last week. Like, who's going to volunteer and say that they did
Right.
that?
So the kind of person who's willing to admit that definitely could be different in systematic ways than the kind of person who used pot but isn't willing to admit that. And that could bias the results. We have to keep that in the back of our mind.
Definitely. And so there's a lot of measurement error going on here.
Yes.
So 77% said they had never tried pot. About 20% were in that 1 to 100 times, and it was only like 2 or 3% that admitted to having pot more than 100 times, which, as we've concluded, sounds like a lot. It sounds like heavy chronic usage, but it might be or it might not be.
Right. But that group is small then, greater than 100. So we have 2 to 3%. Now, luckily, it was a big study. So 2 to 3% of 25,000, it's like 500 to 750-ish.
It was about 600, yeah.
Oh, okay, yeah. So that's not huge. I mean, not tiny, but not huge compared to the other two categories. Of course, Regina, I got to bring up, we do have this thing called healthy volunteer bias. So who chose to give their data to the UK Biobank? These are already healthy people. And like everybody who died of overdosing on drugs is not in the UK Biobank, right?
The people who are too stoned to get off the couch because they're living in their parents' basement and they're unemployed. They're not answering the phone and volunteering to go
They're
out.
not volunteering for the UK Biobank, no. So the people that tend to volunteer for these types of studies, they tend to be healthier, wealthier, more educated. So we do automatically have this bias. And we may be dropping the people who did badly because of pot. Is that
Exactly,
right?
Exactly. So that is also putting a little more skepticism into whatever results we have here. Okay, so results. Let's talk about the brain volume results first. Remember, they looked at those three groups, the none and what they call the moderate, and then the heavy chronic users. And they looked at all three of those groups and at all 18 regions simultaneously in what we sometimes call an omnibus test.
Okay, everything at once, yes.
Everything at once test.
And that actually, we do this because one statistical test, you don't run into the problem of multiple testing. So that p-value has meaning. Right. Yeah, and we start there. Yes.
Mm-hmm. We start there just to see if there is something.
Yes.
And then if there is some sort of signal there, then we can dive a little deeper.
Right. But if there's no signal there, you're not allowed to go any further. That's what controls the multiple testing issue. Yeah.
Right. Okay, so when you're looking overall at all of these brain volume things, the results were highly statistically significant, or as I like to call it, statistically discernible, p-value of less than 0.001.
Oh, wow. But Regina, you said the sample size was over 25,000. And you and I know that when you have a sample size that large with a continuous outcome, pretty much everything will come up statistically significant just because the sample size is big. And as we talked about in the p-value episode, p-values depend on sample size. And when you have a huge sample size, you have extreme precision. So even tiny differences can come out statistically significant. So did they give an effect size here?
They did. Now, they reported a kind of standardized effect size called eta squared. And the eta squared here, Kristen, was 0.001, which is tiny.
Maybe our audience doesn't even need to understand what an eta squared is to know that 0.001 of anything is generally tiny. So, yes, that is a very, very, very tiny effect size. Almost nothing, really.
Almost nothing. So just to kind of bring it into context, remember we talk about Jacob Cohen and how he is famous for his rules of thumb labels on these different standardized effect sizes. And he said that for eta squared, an effect needs to be at least 0.01 before it even can be considered small instead of nothing.
Right. So 0.001 is actually 10 times smaller than something that is barely anything. So this is definitely like essentially nothing.
Tiny.
Yes. Clinically meaningless.
So we have now that going in. But still, let's keep following the trail and see what we have.
That's the omnibus. And so it's possible that there's something within there that's a big effect. And when you squish it all together, you're obscuring it. But so I assume they then, having gotten a significant omnibus p-value, are then going to dig deeper and maybe there's something in there.
So for the digging deeper, they wanted to look at all the individual brain regions, and they wanted to look at where in those three groups we were seeing a difference.
Right. The omnibus p-value doesn't even tell us which group did better. Maybe the stoners did worse.
Right.
Right. So we want to actually ask specific questions about comparing the none to the moderate group and what was the direction of the effect and on which brain region.
Right.
But
exactly.
that brings in a multiple testing issue because now we're doing a whole bunch of statistical tests. So did they deal with that?
They did. So protect against that multiple testing, they reported p-values that were adjusted by the Benjamini-Hochberg procedure to control for the false discovery rate.
Oh, that is excellent. I'm so happy to hear that. That makes statisticians so happy.
Yes,
and it's just fun to say Benjamini-Hochberg.
Yes.
It sounds fancy.
I know you love Benjamini. I don't know Hochberg.
You do?
I do.
Oh,
I worked
in
with
what context?
Yoav on the p-values. Task force.
You hobnobbed with all the bigwigs in statistics when you were on that p-values task force, Regina.
I did, for better or for worse.
Right. I remember you described it in the p-value episode as herding cats. Herding bigwigs, maybe, is another way to put it, yes.
Herding
bigwigs with big egos.
Self-important cats.
Yes.
Okay.
So that's good that they actually adjusted their p-values for multiple testing, because that's a lot of tests. I don't even want to sit here and count how many, but 3 times 18. Did I do that right, actually?
Yep.
Yeah. Oh, well, look at me.
Yep. Okay, so that's a lot right there. Okay, that's the good news, Kristen.
Yep.
Yes. Are you ready for the bad news?
Uh-oh. Yeah.
They pretty much ignored this when they reported their results. So they said, hey, we have 11 out of 18 regions showing some sort of effect. But it was only 11 when you looked at the unadjusted p-values. When you look at the adjusted p-values, only 5 of the 18 were significant.
Why would you ever look at the unadjusted p-values? The whole point is you're controlling the false positive rate, and those aren't controlled, so you ignore those and you only look at the adjusted. So we're just going to say 5 were significant, not 11. The 11 means nothing.
It was funny and sad.
Yeah, they're trying to make things look better than they actually are. Yeah.
Or they were confused. I don't know. Okay, so we have just 5 brain regions that have significant differences between the groups.
Right.
But now we need to go in and see which of those groups were different. But first, I want to give the 5 just for the neuroscientists.
The actual brain regions?
Yeah,
yes.
yeah.
Okay.
It was left and right putamen, whatever that is, the left amygdala, but not the right amygdala, and the left and right hippocampus.
Oh.
So hippocampus, do you remember hippocampus?
I mean, that has something to do with memory, right? Am I remembering that right? Yeah.
You are remembering the memory.
Amygdala is like fear, right? And I don't know the other one.
I don't know the other one either, but the hippocampus is especially important because it's been linked to problems with dementia.
Oh,
so
memory, yeah.
Okay, and when you go in and look at the individual groups.
Right, which groups differed?
You saw that those moderate pot users, 1 to 100 times in their life, had bigger brain volumes in each of those regions than the non-users. But that was it. You couldn't say anything about those greater than 100 times users.
Oh, they were not significantly different than anybody.
Than anything.
Of course, the moderate pot users are a much bigger group. Oh, this is why they collapsed the categories, Regina. It's all clear to me now, because the chronic users, there were only, like 600 or so of them? Well, that's too small to get a statistically significant result on a tiny effect. But if you collapse all the middle groups, then you have a huge sample. 20% of 25,000 is about 5,000. So they now have a category with 5,000 people instead of maybe a few thousand here and there. That's going to make it easier for them to obtain statistical significance on a teeny tiny effect. So we don't know that they did that, but now I have this lurking suspicion that might be the explanation. I would stake quite a bit of money that that's why they collapsed those categories, because it allowed them to find a significant result.
Ooh, this is a plausible story.
So we have several worries here now, Regina, one of which is that these results might be statistically significant but not clinically significant. They may be manufactured through some p-hacking. But let's even just for the moment put all that aside and say there is some actual real association here, not just p-hacked or so small it's meaningless. We still also, even if there was a real association here, have to worry about confounding. People who went to college might have been more likely to use pot, and maybe they're also better cognitive function and brain volume just because they're the people who went to college versus the people who didn't. So did they control for confounding, statistical adjustment in any way?
They did some. They did age in there. They did sex. They used smoking status and alcohol use, but no, they had no income. They had no educational status, nothing about that.
Yeah, and we definitely want to adjust for that. I'm sure that's in UK Biobank, I would think. So I don't know why they didn't adjust for it.
I think it's just another reason for us to be skeptical.
Yeah.
That there's so much that we cannot rule out here to explain the results. Okay, so that was brain volume.
Yes. I'm much more interested, though, Regina. Brain volume doesn't mean a lot to me because, what does that mean? So cognitive tests, they actually did cognitive tests. So I'm dying to know, how did they do in the cognitive test?
So first of all, this was a subset of that big group. They had cognitive test data only from about 2/3 of that big sample.
Okay, so the sample size was down to how much now, Regina?
About 17,000.
Oh, okay.
And remember, the researchers chose 7 cognitive tests to look at. And just to give you a flavor, it was things like reaction time and how well you could remember numbers and how fast you can scan a page and you can learn new patterns and remember them later and how well you can multitask, these sorts of things.
Oh, these actually don't sound so terrible. I'm worried to take a cognitive test because, I'm aging and, I forget things sometimes now. But I actually think I'd do okay on that one because I'm great with remembering numbers. I'm terrible with remembering names, but I have good memory for numbers. And I'm like really fast at scanning a page.
I know you are.
So I might do okay on this.
This is all of the executive functioning.
Okay.
And you are quite...
Not the memory ones that I'd probably fail.
I don't think on these tests they ask you, where are your glasses? And do you remember why you went to the refrigerator and opened it?
Oh my God, I would so fail that test. So yeah, don't give me that one, please. But numbers I can do.
Numbers
Ask me a number from the past. I got it. I'm all over that. Yeah.
How many digits of pi can you remember?
Oh, I never memorized pi. No, that wasn't a thing I did as a kid. Some people do that, but no. Did you do that as a kid?
I got it to 4.
I think that identifies us as a different kind of nerd.
Oh,
yeah,
okay.
Seriously. I think there's a kind of nerd that is memorizing all the digits of pi, and that we are a different kind of nerd, which is why we're more fun. It's kind of like the pot use, though. If you memorize between 3 and 100, that's one kind of nerd.
Okay.
If you've gone beyond 100, you're a different kind of nerd. And then there's us who, know it up to 2. 3.14.
I think we might need to break these into different, smaller categories.
I know we're over collapsing, but I think we could generalize into different categories of nerds. I think there's something to this. This might be related not to cognitive function, but to something else.
Personality.
We should do a study.
You know how Cosmo had those quizzes? What kind of lover are you? What kind of nerd are you?
Okay, so back to the cognitive test. So did they do the omnibus test first?
They did the omnibus test.
And let me guess. Statistically significant tiny effect size?
You got it.
I have seen this before.
You have seen this pattern before. So this is a good cognitive test.
I'm good at recognizing patterns.
You are good at recognizing patterns. And were all the cognitive tests significant? No, they were not. They were not. Only 4 of the 7 showed significant differences.
And this is after correction for multiple testing this time?
After correction, after I went in and used the corrected p-values. And again, the only discernible significant differences were between never using weed or using weed between 1 and 100
The
times.
moderate group, right, yes. But Regina, it would actually be really helpful could you give us an example of one of the differences? How big are we talking? Because we can understand differences on cognitive tests.
Yeah. This one I had to go look up because I didn't know these cognitive tests. Maybe you do. And the one that I liked that might be easy to describe is called symbol digit substitution test. Do you know this one?
I'm familiar with these cognitive tests because I have done some data analysis for others on cognitive test data, so I'm familiar with them. And the symbol digit substitution is basically a processing speed test. So they give you a code. 4 is a dot, 7 is a star, and then they show you a bunch of numbers, and you have to translate to dot and star as quickly as you can and as many as you can. Higher scores better.
Okay.
Yeah.
Well, that helps. This is a little bit of what I saw. So the researchers gave some bar charts, sadly.
So you extracted means off the bar charts. And we've talked ad nauseum about why you're not supposed to use bar charts for continuous outcomes.
I know. It makes me nauseous.
And it's a 2026 paper, so we can't even forgive them being,
No. And so I use graph to table to get the number.
Graph to table. Go graph to table. Normal curve's 20. You get a discount, listeners, if you go and use it. And we use it all the time.
We do use it all the time because I wanted to know what the actual numbers were. So, for example, on this symbol digit substitution, the mean for the never used weed group was about 19.3, and the mean for the 1 to 100 group was about 19.6.
So you're saying this highly significant difference between the two groups constituted 0.3 points on a scale that goes up at least till 19 or 20. That is the definition of clinically insignificant, because if you tell me I can go smoke pot every day and then I'm going to improve on this test by 0.3 points, it's not the reason to smoke pot.
It is going to change your life.
This is not going to affect your memory and remembering what's on the stove at all.
No. And all of the tests showed small differences like this. It wasn't like any of these effect sizes were large. Sadly.
Okay.
So the overall picture?
So I'm not terribly excited, I have to say, by these results. We have this measure of pot use that's very crude. We don't know if it was yesterday or 50 years ago. We have people using it once in their lifetime lumped in with people using it 99 times in their lifetime, and biologically not plausible that those are going to have the same effect. And they see some significant differences between this moderate use group and the never group, but they're very, very tiny differences, so tiny that I'm going to call them clinically meaningless, even though they happen to be statistically significant just because of the big sample sizes.
And only in some regions, but not all.
Right. Only some cognitive tests, not all. Okay. So basically, Regina, I'm going hand the pot to grandma, not so much. I, in fact, think there might be a liability in handing the pot to grandma because we don't want grandma to break a hip. And you're probably more likely to fall if you're on pot. So how in the world did this become a hand the pot to grandma headline? Walk us through the steps, because this sometimes happens when you go from a paper in the literature all the way to the media. Some things get lost in translation. What happened here?
Press release.
Right. You mentioned that we were going to talk about press releases, which we haven't really talked about in great detail in this podcast before. So let me just explain. When you work for a university or a company sometimes and you publish a paper and it's a very interesting paper in a good journal, often there's a communications department at your institution that releases a press release. And what that is they let the media know, hey, this paper's coming out and we're going to summarize it for you. And often whatever is in the press release, the media kind of runs with that because it's already done for you. And so the media may do some independent fact checking and some interviews and things, but they often start or believe or use the numbers from the press release. So there's lots of places where things can get lost in translation, from the original paper to the press release and also from the press release to the media. So what happened here?
Yeah. So let's look at that first step in that chain that we're going. So from results to press release, let me read you a couple of lines, and we're going to focus here on the English wording. The job of the press release is to try to put it into words to make it easier for other people to understand. But this is where things can get lost. All right. Press release said, cannabis use among older adults was generally associated with larger brain volumes and better cognitive function. So cannabis used among older adults sounds like what to you?
It sounds like they're currently using cannabis, or at least recently. Yep.
Okay. Another line said, research found larger brain volumes and better cognitive function among middle-aged and older adults who used cannabis.
Oh, I mean, it's past tense used, but it still sounds like currently. The implication is that they recently used cannabis right before they signed up for the study or whatever.
Right.
They should have said middle-aged and older adults who had used cannabis. That grammar difference makes a big difference because that's telling you that it might be way in the past.
Yes, exactly. And that verb tense is, do you remember this from English class?
Oh, goodness.
I know. It's past perfect or imperfect?
Oh, past perfect, I think.
Perfect.
You're right. Yes, yes.
So if we just had that word had
that would make all the difference, yes.
That would make all the difference. So this is not actually incorrect, but it's a little misleading. But then when the New York Post wrote about it, they took that and very reasonably translated it to, the study found that middle-aged and older adults who use the drug may actually see some brain.
Who use, which is now totally present tense. So they obviously thought present tense.
Of course.
Somebody didn't check the study. This is a reminder to journalists to go back to the original study and check. Don't trust the press release, but yes.
Right.
So they didn't clarify anywhere in the press release that this was
They did not.
past use? Yep.
In fact, the lead researcher, they have a quote from the lead researcher. Okay, I'm going to read you the whole thing. She said, more older adults are using cannabis. It's more widely available and is being used for different reasons than in younger folks, such as for sleep and chronic pain. Plus, people are living longer. We have to be asking, what are the long-term effects of cannabis use as we continue to age?
Okay, so that's a little slippery because she never says in there, we answered that question, but it's an implication that they looked at that question. But they did not look at what is the effect of cannabis use as people age. They didn't have that data.
Okay, Kristen, here's a little bombshell crazy thing. They actually could have gotten closer to answering this whole question about grandma using pot now or grandma using pot 60 years ago. And that's because they had a variable from the UK Biobank that recorded the age that the participant had last used cannabis.
Wait, no way.
Yes.
They had that variable, but they didn't use it?
They used it for a secondary analysis that was just looking at, let me explain what they did. They trichotomized this into never used it, last used it before age 25, or last used it after age 25. And then what they did was anyone who used it after age 25, they threw that data out.
Oh, so they were just asking now a question about young people and cannabis use, which is a perfectly interesting question, but it doesn't sound like that's what the study was focused on.
It doesn't have anything to do with this at all.
Regina, they could have, if they had the last usage, they actually knew who was using it recently and current. Yes. So they should have thrown out the people not using it recently or currently and compared them to the none group to then answer this question about cannabis use while you're aging.
Or even just said, okay, still using.
Right. Or
quit a long time ago, never used.
Somehow incorporated the information on the recency of use into their analysis because they have that variable. Wow.
They threw away information. It's just irresponsible or careless or silly. But this is the whole thing. They could have answered this question about grandma using pot now and whether it's good for her.
Yeah.
It's like they missed the ball. What do you call? I'm reaching for a baseball metaphor here.
Through Bill Buckner's legs. Red Sox reference.
Oh, my God.
1980s. Yeah. For those of you out there who know what I'm talking about.
I don't. You have to explain it to me.
The Red Sox.
I understand.
I'm from New England.
Red Sox are baseball, but who's legs?
The Red Sox didn't win the World Series for many, many, many years. But 1986, I was a kid, and there were one out from winning the World Series, and the ball goes through Bill Buckner's legs on an easy grounder, and then they lose that game, they lose the next game, they lose the World Series. It's the curse on the Red Sox.
Kristen, I am flabbergasted. First of all,
Did I know anything about baseball?
That I would be getting a baseball metaphor analogy that was from you. That was so apt. I am learning so much about you. Yes, these researchers missed the ball through somebody's legs.
Right. The ball went through Bill Buckner's legs.
Exactly what happened, though.
Yes.
It was right there.
It was right there, and they just,
And they missed it. They fumbled.
They fumbled the ball.
Wrong.
Well, it's more than that.
That's the wrong sport. Fumbling is football, right?
I don't know. Okay. I think we are ready to wrap up now, then, and rate the strength of evidence for the claim that, what was the claim, Regina?
Middle-aged and older adults who use cannabis will see some brain and cognitive benefits.
And how do we rate strength of evidence on this podcast with our highly scientific 1 to 5 smooch rating scale, where 1 smooch means little to no evidence for the claim, and 5 smooches means strong, robust evidence for the claim. And Regina, kiss it or diss it?
I'm going to give it 1.5 smooches.
Oh, that's the little optimism in you.
It is.
Yes.
It is. I admit it. I mean, maybe we are just like mice.
Maybe.
It's actually that there's actually just no evidence here. This is a weird kind of study where they could have, but they didn't, so we don't even know.
I even think had they even used that variable, it still wouldn't have told us very much because it's a crudely measured variable. It's observational. There's confounding. There's time periods. It's just, I don't think you can answer the question. Yeah, maybe you can look at something in the data and find a signal, but what does it even mean? I'm going to just go 1 smooch. I'm not going to throw a martini in the face.
Maybe you should throw like a gummy in the face.
I know, that's not as exciting as throwing a drink in the face.
Or blow a bong hit into the face.
Yeah, not as exciting as a martini in the face.
martini.
So martini laced with pot in the face. Is that a thing?
It is a thing.
Is it really? I just made that up.
You can get THC cocktails.
I mean, that makes sense. Okay. I'm going to resist the temptation to throw a THC-laced martini in the face, but I am going one flat smooch. There's no decimal places on this one. There's no evidence here. I mean, this is a hard study to do short of randomizing people. And, maybe because pot is legal in a lot of places now, I don't think a randomized trial is out of the questions. It might be an easy recruiting, right? Free pot.
Okay.
Yeah. I don't know.
Somebody's
going to do it. Yeah. All right, Regina, how about methodologic morals? What do you got for us today?
So I'm fascinated by this game of telephone that we've been seeing here. So my methodological moral is always follow the chain from data to results to conclusions and pay attention to the words along the way.
Things get lost in translation. Yes, absolutely.
What about you?
So, Regina, I'm still going to rant and rave about the collapsing of categories and also the fact that we had results that were clearly statistically significant, but not clinically significant. So mine is huge samples can give tiny differences, delusions of grandeur.
I love that one.
Well, this has been fascinating, and I don't know if we're encouraging or discouraging people from smoking pot. No judgment.
No judgment, either way.
Yeah, either way. But I'm not convinced that it's going to make your brain function better.
But it may not make it function worse.
That's true. Right. There was no evidence of that. So we could take that as if there was some big detriment, you might expect to pick it up in the pot user. So we didn't find that. So that's good. Yeah.
There we go.
The silver lining. Yeah. the pot lining.
The silver pot lining.
Silver pot lining, yes.
All right, Kristen, thank you.
Thanks, Regina, and thanks everyone for listening.